Good morning, Professor and friends. My name is CharuBhattarai. I am a student of ADTA 5560. Currently, I am living in Irving, Texas. So I'm going to give a short presentation on final project presentation for recurrent neural network for sequence data. So let's begin now. So as we all know that COVID-19 is a global pandemic all over the world. So I choose the time series data set of COVID-19. So first of all, in Google Chrome, I search for data.gov, and over there in the search list, I choose for COVID-19 time series metric. Then after that, in next step, I download the CSV file and copy and paste it inside the data folder of Jupyter Notebook. So I have the data folder already present in Jupyter Notebook. If it is not, then we need to create one folder. So it is not that every time it should be inside data folder, but it can be any folder, but the path should be correct when we write the algorithm. At that time the path should be correct. So I use a data folder. Then in that COVID-19 data set, we have data from April 22 2020 till March 3rd 2022. So it has 8 different attributes, which are demographic category, demographic value, total case, percent case, death, percent death, percent of CA population, and report date. So report date, it is in date format, and the percent cases, percent death, and percent of CA population is in percentage format, and remaining are in integer format. So in my data set, there are altogether 11,824 rows of data, which is in CSV format. So after going through the data set, I found that on March 3rd, 2022, this year, just few days back, the highest total case of COVID-19 was found on that day. Also, the total death of COVID-19 was highest on the same day, March 3rd, 2022. So as we all have the full dose vaccine, so hopefully in upcoming year, in upcoming days, the death rate and the total case will be less. Let's hope for it. So I have built, train, test, and forecast this data set using recurrent neural network and long short-term memory neural network, and also rebuild it for better performance and accuracy. So let's discuss about it in more detail in our next slide. Okay. So first is, I have built, train, and test the data using Kira's sequential model of simple RNN. So in this part, I have build the data, train the data, and test the data set using the simple RNN, recurrent neural network. So while doing so, I have it has total neurons of 80 and 8 epoch, and batch size is 1, and the length of the number of steps of the input time series is 50. So in using all of these value, I have performed the required steps to build, train, and test our model. So what I found is during model evaluation of RNN, during this period, first data point was dropped and new batch was generated to prepare for the first iteration of testing. Here 50 steps of time series were maintained. While testing the data, the prediction was not that much deviated from the sine wave. So after completing this testing, what I found is the result was not accurate, was not appropriate. So in next step, I decided to use, I decided to follow the, I decided to move ahead to build, train, and test the data using LSTM. So, okay, so LSTM cell. So there, what I did is in part 4 of a final project, I have used COVID-19 cases demographic.csv as a data set, build, train, and test the model using the Kiraj sequential model of LSTM neural network with COVID-19 dataset, successfully perform the following steps. Build an LSTM neural network using the Kiraj sequential model. This layer has 50 LSTM cells. Train the model using the training dataset of COVID-19, part of the collected dataset. Test the model using the testing data that has been allocated from the collected dataset. Generate time series batches for training testing. Set the length of the input sequence equals to length 500 and the batch size is 1. Retrain the model using the whole collected dataset and prepare it for forecasting. Perform the forecasting using the retrained model. Ran all the steps of this part, I mean this project, in a Jupyter notebook document to get the result of each steps. So using LSTM cell equals to 50 and the length equals to 500 and batch size equals to 1 and all the required value, I ran the model. I build, train, and test the model using LSTM neural network, and the performance and accuracy rate was slightly better than RNN. That is the in comparison to RNN, that is the recurrent neural network. So I decided to move ahead for more accuracy rate, for better performance. I redesigned the model using LSTM neural network. So let's discuss about it. In part 5 of final project, I have used COVID-19 cases demographic.csv as a data set and then redesign the model and again rebuild, train, and test the model using Kiraj sequential model of LSTM neural network with COVID-19 data set for more accuracy and performance improvement. Successfully, I have performed the following steps. Build an LSTM neural network using the Kiraj sequential model. This layer has 60 LSTM cells. Train the model using the training data, part of the collected data set. Test the model using the testing data that has been allocated from the collected data set. Generate time series batches for training testing. Set the length of the input sequence equals to length equals to 600 and batch size is 1. Retrain the model using the whole collected data set and prepare it for forecasting. And while forecasting, we need to give the value of the epoch. So as I noticed that the more the value of the epoch, the more time it takes. So I use epoch equals to 1 so that I can run the model in less time. So apart from that, I have used length equals to 600 and batch size equals to 1. Also the layer, this layer has 60 LSTM cell. So I performed the forecasting using the retrained model. So in final step, I ran all the steps of this project in Jupyter notebook document to get the result of each steps. So while designing the model, I found that the performance is very much increased in comparison to the RNN performance. So in this final project, we have also discussed on the core concept of LSTM cell and its gate. So what is the LSTM cell and its various gate, like for gate input and output gate, also the similarities and differences of LSTM cell and the hidden state in simple RNN. I have also wrote an overview in my final project document. So this figure, it shows the LSTM recurrent neural network flow chart. So in order to compare the network performance of recurrent neural network RNN and LSTM long short-term memory neural network, and also redesign the LSTM long short-term memory neural network, I compare the network performance, and based on the design and the core parameter applied to the LSTM neural network in part 3 and the network in part 4, comparing its percentage, comparing its performance is increased. The performance is increased while redesigning the LSTM network. So initially in part 4, I have said the length of the input sequence is 500 and this layer has 50 LSTM cells. But in part 5, while redesigning the neural network, I have said the length of input sequence is 600 and this layer has 60 LSTM cell. So I have increased the length by 100 and the layer of LSTM cell by 10. So after that, I have built, train, and test the model. So let's see how it works. Does the performance increase or not? I'll explain you. Yeah, let's go ahead. Also, while redesigning neural network, I have set the batch size value equals to 1 for 60 historical data points. Although, so for both part 3 and part 4, I have set the batch size value equals to 1 for 600 historical data point. Although adding new neuron and layer number are beneficial to improve the prediction accuracy, and it will also increase training difficulty. It consumes a lot of computing power and time, but does not necessarily improve prediction performance. Increasing the number of layers provide a shortcut to increasing the capacity of the model with fewer resources, and modern techniques allow learning algorithm to successfully train deep model. Increasing epoch will increase the test accuracy to increase. If the test accuracy start to decrease, it might be that your network is overfitting. So in this way, we can test whether the test accuracy, we need to monitor whether the test accuracy start to decrease or it increases. But while we increase the epoch, we will increase the test accuracy to increase. So epoch is one of the main component. So the more the epoch value, the more chance of accuracy, test accuracy, to get the more test accuracy rate. So accuracy will increase with more hidden layer, but performance will decrease. So the accuracy of our model will increase with more hidden layer, but performance, the chance for the performance to decrease. But accuracy not only depend on the number of layers, accuracy will also depend on the quality of your model and the quality and quantity of the training data. So it is not only that the accuracy depend on the number of layer, but accuracy also depend upon the quality of your model and the quality and quantity of the training data. So the neural network often learn faster when the example in the training data set sum to 0. This can be achieved by subtracting the mean value from each input variable called centering. Convergence is usually faster if the average of each input variable over the training set is close to 0. This work purpose the use of artificial neural network to approximate the objective function in optimization problem to make it possible to apply other technique to resolve the problem. The objective function is approximated by a new non-linear regression that can be used to resolve an optimization problem. So non-linear regression can be used to resolve an optimization problem. If we are working on a classification problem, the best score is 100% accuracy. If you are working on a regression problem, the best score is 0.0 error. These scores are an impossible to achieve upper lower bound. When neural network reduces loss, the solution to this are to decrease your network size or to increase dropout. For example, you could try dropout of 0.5 and so on. If your training validation loss are about equal, then your model is underfitting. Increase the size of your model, either number of layer or the raw number of neuron per layer. So to increase the size of the model, we need to increase so to if our model is underfitting, then at the time we need to increase the size of our model, either the number of the layers or the raw number of neurons per layer. So here are the two diagrams which shows the sequential processing in RNN. The first diagram, it is showing the sequential processing in RNN, and the second diagram is showing the sequential processing in LSTM. So in overall conclusion of a project report, RNN, so in first part I have built, train and test the model using RNN. In second part, I have built, train and test the model using LSTM using the COVID-19 data set. And in the third part, I have built, train and test and forecast the model using, I have rebuilt and redesigned the model for COVID-19 data set. So what my overall conclusion is, while redesigning and rebuilding the LSTM model using COVID-19 cases demographic data set, the performance and accuracy rate is better. So better to use LSTM in comparison to RNN. So let's discuss about it in more detail. So in overall conclusion, LSTM should be preferred in comparison to RNN because it introduces more controlling knob. LSTM, it introduces more controlling knob. Moreover, LSTM, the knobs in LSTM control the flow of input as per the train weight. Also, LSTM gives more flexibility in controlling output. LSTM also provide more contour. ability, which means that ability which lead to better result as compared to RNN. So LSTM, that is the long short-term memory neural network, has more advantage in comparison to RNN, recurrent neural network. So my suggestion is better to use LSTM. I prefer using LSTM in comparison to RNN. LSTM has high computational complexity because it includes a memory cell for maintaining information in the memory for longer period. Since the LSTM has more power and additional architecture for resolving issue of vanishing gradient problem in RNN, the major benefit of LSTM network over RNN are that we are introducing more and more controlling knob which control the flow and mixing of input as per train weight, and thus bringing in more flexibility in controlling the output. So LSTM gives us the most control ability and thus better result. So in this way we can clearly understand that why LSTM is better and why LSTM has the vanishing, we may face the vanishing gradient problem in RNN neural network. So LSTM, RNN doesn't have the resolution for this kind of problem. So in that case, we can use LSTM so that our our problem like a vanishing gradient or there may be any other issue while in our model. So all of those issues we can solve using LSTM. So LSTM, it will give the most control ability in comparison to RNN. And also LSTM has more controlling knob, and so LSTM, it gives more flexibility in controlling output, and it introduces more controlling knob, keep knob control the flow of input as per the train weight. So should be, and because LSTM has more memory cell for maintaining information in the memory for long period of time. Since the LSTM has more power and additional architecture for resolving issue of gradient. So similarly in our this sequential processing, we can increase the these are the input and these are the output. So we can increase the number of input, and then hence the output will also get increases. But in sequential processing for LSTM, we can see that it is different. So when we give the input, so if t, we need to assign the value of t, and the output will goes accordingly. Similarly here also we can assign the number of input, and hence the output will generate on the basis of that. So in so input layer, processing, and output layer, so it has some hidden layer as well. So here it needs some computational so that our performance and the accuracy rate will be accurate. So it has some, LSTM also has some cell like input gate, output, and for gate, hidden layer. We need to understand about those. And yeah, so So as I already discussed that if you are working on a classification problem, the best score is 100% accuracy. If you are working on a regression problem, the best score is 0.0 error. These scores are an impossible to achieve upper lower bound. When neural network reduces loss, the solution to this are to decrease your network size. So while redesigning our model, we need to decrease the network size or to increase dropout. Because when the neural network reduces loss, then the solution for it is to decrease your network size or to increase dropout. For example, you could try dropout of 0.5 and so on. If your training validation loss are about equal, then your model is underfitting. Increase the size of your model, either number of layer or the raw number of neurons per layer. Accuracy will increase with more hidden layer, but performance will decrease. But accuracy not only depend on the number of layer, accuracy will also depend on the quality of your model and the quality quantity of the training data. So increasing the number of layers provide a shortcut to increasing the capacity of the model with fewer resources and modern technique. Allow learning algorithm to successfully train deep model, increasing epoch with increase the test accuracy to increase. So based on all of these aspects, I preferred using LSTM, redesigning the LSTM. If the performance rate is not accurate, then redesign the LSTM neural network. So in comparison to RNN, LSTM has so many advantages. So I prefer whenever we build, train, test, and forecast the model, I preferred using LSTM. So that's all from my side. Thank you.